This clip looks at one of the main methods of solving simultaneous equations called the method of substitution. To do this, I'm going to use a couple of examples from Maths Quest 11. The two equations we're going to solve are y equals 3x plus 1 and y equals 2x plus 2. Normally, we call these equation 1 and 2 to label them. In this method, what we're going to do is we're going to substitute equation 2 into equation 1. Now, equation 2 tells us that y is equal to 2x plus 2, so we substitute this value of y up into equation 1. So by doing that, we'll have 2x plus 2 equals 3x plus 1. Now we do some algebraic manipulation to solve this equation for x, because it only has one unknown quantity in it, which is x. So we have one equation, one unknown, and we can solve it. What I'm going to do is I'm going to subtract 3x from both sides. In that way, we eliminate x from that side of the equation, and on this side of the equation, we have negative x plus 2 equals positive 1. Now we're going to remove this from this side of the equation by subtracting 2 from both sides of the equation. The reason I do that, it eliminates that from that side of the equation, and we end up with negative x equals negative 1. Negative x equals negative 1, then we can say x equals 1. Now to find y, we substitute x equal to 1 into one of the equations. So that's what I'll do. Substitute x equal to 1 into equation 1. Equation 1 is y equals 3x plus 1. Substituting x equal to 1 in that, we have y equals 3 times 1 plus 1 equals 4. So the solution set is x equal to 1, y equal to 4, which we write as 1 comma 4. Just remember also, this is what is actually meant by it. If we have these two linear equations, they both can be drawn as straight lines on a coordinate system, and the point where they intersect will be the point whose coordinates are 1 comma 4. Just going back over that method, what we do is we substitute the second equation into the first. The second equation says y is 2x plus 2, so we place this y up here with 2x plus 2, which we've done there. We then manipulate algebraically that by solving the equation. We do that in this particular case. We notice that we want to get this x to this side of the equation, so we subtract 3x from both sides of the equation, and so we have x on this side of the equation. Now we need to get rid of the numbers on this side, and to get rid of the 2, we subtract 2 from both sides, and we get x equal to 1, and then y is found by substituting x equal to 1 into one of the equations. You can substitute into equation 2 if you like. It doesn't really matter. You'll still get the same answer. The second example where we're going to use the method of substitution is a bit more complicated and also involves some algebraic fractions which might confuse you. Let's hope not. In this particular example here, equation 1 is y equals negative 2x plus 3, and equation 2 is negative 5x plus 2y equals 1. What we're going to do here is we're going to substitute y into the second equation. So substitute y equal to negative 2x plus 3 into equation 2. If we do that, we'll have negative 5x plus 2 times y. Now y is negative 2x plus 3. So we've substituted in y, the equation 1, the value of y from equation 1 into equation 2 equals 1. We'll call that equation 3. Now what we do is we tidy this up by doing some algebraic manipulation. We have negative 5x. Using the distributive law over this will be 2 times negative 2x, which will be negative 4x, and 2 times positive 3, which will be positive 6, equals 1. Collect up the like terms. Negative 9x plus 6 equals 1. Take 6 from both sides. Negative 9x plus 6 minus 6 equals 1 minus 6. That gets rid of that. And then we have negative 9x equals negative 5. Now we divide both sides of that by 9 so that we can find out what x is. Actually, we'll divide it by negative 9 because that will be a bit smarter. And we'll have x is equal to 5/9. I divided by negative 9 here because I realised that negative 9 divided by negative 9 is positive 1. So if I do that, this negative 9x becomes positive x. But over here, the negative 5 has to be divided by negative 9. So you get negative divided by negative, which is positive, so 5/9. So x is 5/9. Just in the same way as we did before, we now substitute this value back into one of the equations. And I think I'll substitute it into equation 1 because that's a simpler equation. Equation 1, going up to have a look at that, is negative 2x plus 3. Y equals negative 2x plus 3. Substitute in the value of x, and we have y equals negative 2 times 5/9 plus 3, which is negative 10 over 9 plus 3. Working on some fractions here, we'll get that y is equal to negative 10 plus 3 times 9 over 9, which is negative 10 plus 27 over 9, which is 17 over 9. So the solution set is x is 5/9, and 17/9. What that means is that those two equations, if you drew them as straight lines on a graph, would intersect at the point 5/9, 17/9.